Right, hello again, and this time we are looking at if-let in Rust. The if-let syntax lets you combine if and let into a less verbose way to handle values that match one pattern while ignoring the rest. So, just like here, um, you could write this with a match expression, right? Here, this is the pattern. This is one arm, right? And this is the other arm of match. If the pattern fits, so if config max has this pattern, then match is going to return this piece of code. Otherwise, if config max matches any other pattern, it's going to return the unit type, which is like no value. Consider the program in listing 6-6 that matches on an option U8. So this is U8 type option, unsigned integer 8-bit value in the config max variable. Right. But only wants to execute code if the value is the sum variant. So let me just copy this here. Paste it. We don't really need this anymore. Okay, here, this is basically, this is the same as 3, but its type is U8, right? So this is how you can indicate types in Rust. If you just type 3 here, its type is going to be i32 by default. So any integer interliteral like this is going to be assigned the type i32 by Rust by default. If you want to change the type to some other type of integer, like unsigned 8-bit, you have to indicate that like this. Okay, so here you have the config max variable, and it's assigned the value of sum to U8. The use of sum is like it's like an option enum, right? And sum means this value could, and there is a possibility of the value being none, right? So you, by using sum, you enable the checks of the compiler on this value here. And if it's, you have to handle all cases where it might be none, the null case, that is, in other languages. Okay, and here you have the match expression, as I said. If this is the pattern of config max, so sum with a variable, you're naming it max. You can name this anything you want, right? So you can name this value, for instance, and then use that value in your return, right? So some value, let me enlarge this. Whatever you type here, you can use that in the return expression here of the pattern. And this underscore is a catch-all for anything other than the option type that's indicated here. And anything other than sum with a U8 value basically is going to return a unit type. Okay, so if-let lets you write this code a little bit differently, a little bit more concisely, let's say. If the value is sum, we print out the value in the sum variant by binding the value to the variable max in the pattern. So you indicate the variable name here yourself, and then you can use it in your return expression. We don't want to do anything with the none value. To satisfy the match expression, we have to add underscore, arrow, and the unit type after processing just one variant, which is annoying boilerplate code to add. Instead, we could write this in a shorter way using if-let. The following code behaves the same as the match listing. Match and listing 6-6. So instead of doing this, you could type if let sum max config max, and then just type whatever the code is going to do in case the pattern is matched. Right. Okay, so this is basically the same as this code, right? I think after let you have a pattern. That's why let is used here. And this basically says the syntax if let takes a pattern and an expression separated by an equal sign. So this after let, the first expression is the pattern to match and an equal sign, and after the equal sign you have the expression itself. It works the same way as match, where the expression is given to the match and the pattern is its first arm. Right? So in match you have this as the first arm. With if let, you first have the pattern itself, and then whatever is being matched to that pattern. In this case, the pattern is sum max, and the max binds to the value inside the sum. So here, if you're supplying it config max, you have sum3 u8. So max binds to this 3 u8 value. We can then use max in the body of the if let block in the same way we use max in the corresponding match arm. Yeah. Okay. The code in the if let block isn't run if the value doesn't match the pattern. So if this pattern matches whatever shape config max is, then this code is run, but otherwise nothing happens. Using if let means less typing, less indentation, less boilerplate code. Because with match you have to be exhaustive, like all variants need to be, or all possibilities need to be exhausted here, right? You can't leave this out. But with if let, you don't need to do that. However, you lose the exhaustive checking, that match enforces. Choosing between match and if let depends on what you're doing in your particular situation, whether gaining conciseness is an appropriate trade-off for losing exhaustive checking. Right? So it's up to you. If you feel like you should have exhaustive checking of match, and don't use if let. In other words, you can think of if let as syntax sugar for a match that runs code when the value matches one pattern and then ignores all other values. We can include an else with an if let. The block of code that goes with the else is the same as the block of code that would go with the underscore case in match. That is equivalent to the if let and else. So here, and that is the else case, right? This thing. Here's an example with that. We can include an else with an if let. Okay. Recall the coin enum definition in listing 6-4, where the quarter variant also held a US state value. If we want to count all non-quarter coins, we see while also announcing the state of the quarters, we could do that with a match expression like this. Let me type that. Let me count. We're counting the coins, right? unless they are a quarter with a state, which is interesting. Okay, match coin, and then we have the coin quarter state. Print line. State quarter from debug state. I don't have access to the code anymore, so let's make those enums again. Thing we need to do is derive debug here with the enum coin, and you have a quarter here with US state. And US state is also, was it a struct or an enum? I don't know. Let's go back and see. Come down here. No dice rolls. Where's Alaska? All right, so it was an enum. Let's do that. Enum US state. And Alaska. Ala. The other way around. There we go. And other states. Quarter US state. Okay, let's do this after the other enum. Why are you doing this? It doesn't implement debug. Okay, let's make it implement debug. Okay, now match coin. And let's go back here. You're matching coin, which doesn't exist. So let's get a coin. Let coin quarter, and then Alabama. All right, now we should have a kind of a working program here. Right, we're matching this pattern and printing something. And then everything else we are just gonna add to the count with. And then after that, we could probably print the count. Print line. I'm just gonna do count. Let's cargo run. State core from Alabama, count 0. Right. Now, if the coin was something else, like a penny or a nickel, then the count would have increased by 1, right? So if we do a for loop, control flow, where are my loops? There we go. Looping repeating code with loop. And we do a looping version of this. So loop, and then do this. What's happening here? State. I'm not borrowing anything, am I? Coin quarter state. Let's try and run this and see what it is saying. Value moved here in previous iteration of loop. Right. Okay, so if you're looping, there is a move going on. This does not implement the copy trait. Can we derive copy? There we go. No, cannot be implemented for this type. Why not? Dang it. Oh my god. I am very bad at Rust. Okay. Borrow this binding in the pattern to avoid moving the value. So how do I do that? I have to do this. Mismatch types. Coin. About that. Nope. State. This doesn't work. Anyway, so I can't just loop willy-nilly just like I could in other programming languages, which sucks. Alright, I won't be able to do what I wanted to do here. So let's just continue on. I wanted to actually increase count by counting a bunch of coins, but I guess it's not possible. Anyway, let's move back to if let. Okay, so this can be written or can be coded in a different way. Let me get you here. Let's type that. If let coin order state, and you make a coin. Okay, if let coin quarter state coin, if coin matches this pattern, then we are going to print line and say state or from whatever state. Not including that exclamation. Okay. Okay, so that is the first part of the match expression. Now the else part catches the other thing. Everything else, everything that doesn't match the... And I should be able to actually run this. State quarter from Alabama. Okay, so that is if let. Just the same as a match expression with two arms here. One arm doing something based on a pattern, and the other one just catches all other patterns. If you have a situation in which your program has logic that has two verbose to express using a match, remember that if let is in your Rust toolbox as well. Okay, sure. We've now covered how to use enums to create custom types that can be one of a set of enumerated values. We've shown how the standard library's option T type helps you use the type system to prevent errors. When enum values have data inside them, you can use match or if let to extract and use those values, depending on how many cases you need to handle. So if you have only two cases, one that matches a pattern and one that matches everything else, you can use if let. That's basically it. Your Rust programs can now express concepts in your domain using structs and enums. Creating custom types to use in your API ensures type safety. The compiler will make certain your functions only get values of the type each function expects. In order to provide a well-organized API to your users that is straightforward to use and only exposes exactly what your users will need, let's now turn to Rust's modules. Okay, sure. Packages, crates, and modules. All right, I'll continue on with this in the next video. See you guys then.